Is common cold a COVID defense? One of the most striking aspects of the COVID pandemic's early stages has been the virus's seemingly haphazard spread. After exposure, why does one person get sick while another remains unaffected? Scientists at Imperial College London, ICL, have published a paper in Nature Communications that reveals the common cold may be a factor in the COVID infection lottery. People who get T-cells made by other coronaviruses can recognize SARS-CoV-2, but this new study is the first to see how having these T-cells at the time of exposure to SARS-CoV-2 affects whether someone gets sick. Most persons in the UK had not been infected or vaccinated against SARS-CoV-2 at the time of the study's start date in September 2020. It is important to note that the researchers only looked at healthy, uninfected people who were living with a COVID-infected person. In order to find out whether anybody had contracted an illness, participants were tested twice more, on days 4 and 7. The researchers then compared these infection rates to levels of pre-existing T-cells produced by past common cold coronavirus infections, which similarly recognize proteins of the SARS-CoV-2 virus. Some subjects had COVID infections while others did not. Those who were uninfected had considerably larger amounts of cross-reactive T-cells than those who were infected. Is there any way we can use these T-cells to our advantage in our fight against a worldwide epidemic? Is it a good idea for us to visit our local daycare center to see whether anybody there has the sniffles? In addition to being a bad idea, we may have a hard time finding someone to acquire a cold from. Personal hygiene standards, mask wearing, and social isolation have led to a dramatic decrease in the number of respiratory infections throughout the world during the pandemic, which might even lead to the extinction of one strain of flu. As a result of this T-cell defense, there are a number of ways to get around it. A second-generation, universal vaccination that might protect against existing and future SARS-CoV-2 variations, including Omicron, could be built on the results of this study, according to the researchers. Current vaccines target the spike protein on the virus's surface, which has proven problematic for long-term vaccination efficacy. Vaccine escape mutants have evolved as a result of this selective pressure. According to the findings, T-cells assault the virus in a way that existing vaccines are unable to. They target internal proteins inside the SARS-CoV-2 virus. Vaccines that target internal proteins via T-cells, in addition to our current effective spike protein targeting vaccines, could provide significantly longer-lasting protection, according to the researchers, because T-cell responses last longer than antibody responses, which fade out within a few months of vaccination. Kundu emphasizes that our ideal approach is one that integrates as many defenses as possible, even if this new knowledge into our immunological response to COVID might be essential.